In this video, we are going to derive mean variance MGF moment generating function of binomial random variable. Before enter into the derivations, we first go through the binomial expansion formula a plus b the whole per n. The expansion actually contains n plus 1 terms. The expansion has the terms nc0 a power n b power 0 plus etc plus ncn a power 0 b power n. It can be written in the summation format sigma rs0 to n ncr a power n minus r b power r. Here ncr means combinations in formula, selection of r items from n items, and the formula is n factorial by n minus r factorial into r factorial, and the equivalent notation is also given in the right side of the screen. This binomial expansion formula is a plus b the whole per n. Suppose if we consider the term a plus b the whole per n minus 1, the expansion contains totally n terms and it is given in the right side expansion. It can be given in the summation format as sigma r is from 0 to n minus 1, n minus 1 cr a power n minus 1 minus r b power r. In this the summation, if we change variable r as r minus 1, then the index value r from 0 to n minus 1 becomes r is from 1 to n. So we can write the previous term as sigma r is 1 to n minus 1 c r minus 1 a power n minus 1 minus r minus 1 b power r minus 1. We need this alternate summation format for a plus b the whole power n minus 1 because simplification steps in mean and variance of binomial random variable needs this steps. In the same style, a plus b the whole power n minus 2 can be written as sigma r is 2 to n minus 2 c r minus 2 a power n minus 2 minus r minus 2 into b power r minus 2. Here, mean and variance of binomial distribution are going to be derived. Now consider the probability mass function of binomial random variable, which is p of x equal to r equal to ncr p power r q power n minus r. Actually, the meaning is out of n trials, the probability of getting r success is given here. Now the mean derivation e of x that is expected value of x is known as mean, which is given here sigma x into corresponding probability value. Actually, x random variable takes the values from 0 to n because out of n trial means success can be either 0 time, the event didn't happen at all, and out of n trials n times we can achieve success sometimes. So the maximum value of random variable is n. So 0 to n is the parameter. 0 to index varies from 0 to n. Instead variable we enter r, and the corresponding probability value is ncr p power r q power n minus r. So in this summation, we have actually r in the numerator and r factorial in the denominator. That r factorial can be written as r into r minus 1 factorial, and 1 r in the numerator and denominator we can cancel both, and if we cancel the term, automatically r values, the parameter values will be changed into 1 to n because the 0 case will be eliminated. So sigma varies from r is from 1 to n factorial by r minus 1 factorial into n minus r factorial into p power r q power n minus r. Now numerator term n factorial can be splitted as n into n minus 1 factorial, and from the p power r we can take 1 p out. This n and p have no r, therefore they are just constants. We can take both of them uh, outside. So np is now taken out. The balance entries are n minus 1 factorial by r minus 1 factorial n minus r factorial p power r minus 1 q power n minus r. We are doing all this modifications because the summation, actually original summation contains n and r. Instead, we are having n minus 1 and r minus 1. So changing each and every term in the summation expansion as yeah, in terms of n minus 1 and r minus 1. P power contains already r minus 1, there is no problem. And the denominator term n minus r and q power n minus r are going to be made as terms which contains n minus 1 and r minus 1. For this purpose, we are going to add and subtract 1 in both of the terms. So the expansion, that summation contains np into sigma r equal to 1 to n minus 1 factorial, p power r minus 1, q power n minus 1 minus of r minus 1. And denominator contains r minus 1 factorial into n minus 1 minus of r minus 1 factorial. Since we are adding and subtracting 1, that means actually 0 is added. That will not disturb the value of any of the terms. Our ultimate purpose is to make the whole summation as a single entry. Now we can compare this sigma term with the beginning expansion, binomial expansion formula format. So this is nothing but p plus q or q plus p the whole power n minus 1. So outside np, and the balance sigma portion is equivalently given as q plus p the whole power n minus 1. But p plus q value is 1, therefore the next step we have np into 1 power n minus 1, and 1 power anything is again 1, therefore the value is finally simplified as np. So mean of binomial random variable is np. Next step is to find the variance of the binomial random variable. Variance of x equal to e of x square minus e of x the whole square. See, in this right side formula, e of x we already obtained, which is nothing but mean just now, but we don't have e of x square. So the next step is to find e of x square. E of x square is sigma x square p of x, that is r is from 0 to n, r square n c r p power r q power n minus r. Here, numerator contains r square and NCR expansion contains r factorial in the denominator. So cancellation also gives some sigma term with r. So removing r totally from the numerator, we need some extra inclusion here. That's why we are adding and subtracting r here, that is r square plus r minus r, and the balance terms are as usual. Now this r square plus r minus r is splitted as r square minus r in for one sigma part, and totally this r term is taken as the second part of the sigma. Total sigma is splitted into two terms which contains r square minus r in the first expansion and r in the second expansion. In the first sigma, we are taking r out, so it becomes r into r minus 1. And the second sigma portion, it is nothing but simply mean. We even no need to evaluate the second part of the sigma, it is simply np. Now come to this first sigma, it contains r and r minus 1 in the numerator, and if we expand r factorial, it can be directly written as r into r minus 1 into r minus 2 factorial. So cancelling r and r minus 1, and the remaining entries n factorial p power r q power n minus r, and the denominator contains r minus 2 factorial n minus r factorial, and the second sigma portion is automatically np. Now this r and r minus 1, both the terms are cancelled. If we cancelling both the terms, automatically r varies from 0 to n becomes r varies from 2 to n. Now that expansion sigma term becomes n into n minus 1 p square, because we are taking n and n minus 1 from n factorial, and from p power r we are taking p square out. So the totally previous sigma becomes sigma r is 2 to n, n minus 2 factorial p power r minus 2 q power n minus r, and r minus 2 factorial into n minus r factorial plus np, which is second sigma portion directly taken from mean value. Now each of the term we write n minus 2 r minus 2 format. So p power r already it has r minus 2, q power n minus r and denominator n minus r, both the terms are going to be converted in terms of n minus 2 r minus 2. For that purpose we just add and subtract 2. So finally we are having the next step, and compared with the previous binomial expansion formula, it is simply equivalent to q plus p the whole power n minus 2. Hence we have n into n minus 1 p square into q plus p the whole power n minus 2 plus np. We know p plus q is 1, therefore simplification gives n into n minus 1 p square plus np, expanding n square p square minus np square plus np. Combining second and third terms, we will get np into 1 minus p, and first term already n square plus p square. 1 minus p is nothing but q, therefore e of x square is finally derived as n square p square plus npq. Now calculation part of variance, it is e of x square minus e of x the whole square. E of x square as per derivation n square p square plus npq minus e of x, that is mean square is np the whole square. Again simplification, that is n square p square is cancelled. Finally we get npq. Thus variance of the binomial random variable is npq. Now moment generating function MGF is going to be calculated here. E of e power tx is m of t, that is moment generating function. As per definition, sigma, it is equal to sigma e power tx p of x. If we write in the equivalent form, it is sigma r is from 0 to n e power t r ncr p power r q power n minus r. We just check the powers, that is e power tr and p power r. So e power t and p both has same power, therefore we can combine them as a single term. So it will become sigma r is from 0 to n ncr p e power t whole power r q power n minus r. So if we compare this right side with the binomial expansion, it will be equivalent to q plus p e power t whole power n. So m of t is equal to q plus p e power t whole power n. So moment generating function is subtime.